Hello everyone. In this video, we are going to learn about the introduction to machine learning. Learning paradigms. There are three learning paradigms. Number one, generative modeling. It learns the joint probability distribution of variables. It uses Bayesian networks and probability density functions. Generally, this model is good for some unknown situations, perception and temporal modeling. Some of the applications includes NLP, speech recognition, object tracking, face recognition. Number two is discriminative modeling. So whenever there is a need to model a posterior probability or decision boundary, we go for this. And it mainly focuses on the task specific criteria. The best example would be SVM. It's less reliant on some prior knowledge. Some of the applications includes classifying a document and recognizing a character. Number three is imitative learning. Here the agents learn by imitating some examples of interaction. This paradigm is useful for modeling the behavior and autonomous agents. Next we shall learn about the learning concepts, methods and models. The first one is rote learning. It's a traditional form of learning. It focuses on memorization. It's useful for some repetitive tasks. Also, it saves the computation time, and some of the examples include selective paging and caching. The second model is to learn from observations, learning from agents. So, it's a computational entity that perceives and acts. Generally, it learns from the environment through the observations and interactions. So, this is composed of a learning element, a performance element will be there, a curiosity element would be there. For example, let us consider a sales agent which is adapting to the customer preferences. You could see this. This is a agent. Yes, there are some observations. So it's learning from the environment through these observations based on which it performs some action. Also, you could see it includes the knowledge base, algorithm, the training experience based on which it does the action. Number two is inductive learning. It learns patterns from examples and forms generalizations. It generally uses the structured knowledge along with the statistical inference. So, based on the limited data, which can lead to broader conclusions. For example, if we want to recognize the parrots by means of observing birds, so this is supporting some low cognitive decision making. Number three is decision tree learning. It's again a form of inductive learning, but we use a lot of if then rules. So it's representing the decisions via a tree of attributes. Moreover, this is very good for the classification problems with some discrete outputs. Let us say, for example, we want to make a decision whether to play cricket based on the weather and temperature. So this is the decision tree. So the attributes we can find, based on the conditions, say based on the weather and temperature, are we going to play cricket or not? So this is sunny and we are checking the temperature again. Based on the temperature, we decide whether we are going or we are not going. You look at here, this is rainy. So if it is rainy, the decision is no, we are not going. The decision is not to play the cricket. So this is a kind of a decision tree that is formed. So these three comes under the learning from observations. Number three is supervised learning. Supervised learning, it uses the labeled data for training. So what's a labeled data? The data tagged with some correct outputs. We'll have documents along with the classes to which it belongs to. This classifier, it learns to map the input data to the correct categories. The classifier will be trained on some training samples. So when I say training samples, it includes input and output examples based on which we will be training the classifier. What that classifier does is it will learn the features to classify our unseen data. When we feed some new data, it will be capable of classifying it based on the training. It does the classification using a hyperplane. It's going to separate the classes using a hyperplane. For example, let us take document classification. So the documents are the inputs which are represented as data points. The output would be to decide whether the document belongs to A class or B class. How the separation is made? The learning algorithm is going to define a hyperplane. It's defining a boundary based on which we classify the new documents. This is a very simple picture which tells you how far a hyperplane is used to classify the points here. So these points belong to class A and these points belong to class B. And when the classification is done, there will be some errors. As you could see the confusion matrix here, yes, if the actual label is positive and the machine also predicted as positive, it is true positive. If the actual classification is negative and the prediction is also negative, it is true negative. And we have a type 1 and type 2 errors. So this false positive, we are wrongly classifying it as a class. So actually it is negative, but the model is classifying it as a positive. So we are wrongly classifying it as a class. When I say false negative, it is rejected though it belongs to the class. So actually it is belonging to the positive class, but we are predicting it as negative. So we are rejecting it though it belongs to the class. So in this case, it's very severe that the correct identity is missing. The main goal is we want to minimize the false negatives. Also, we need to ensure that the classifier is generalizing. It's performing well to the new data. Unsupervised learning. Unsupervised learning, it's a learning happens without unlabeled data. So there will not be any predefined classes or labels. Mainly it relies on the similarities and differences. When we ask a child to distinguish group cars and boards, so based on the features it does the grouping. So early learning uses some visible characteristics for that grouping. The same process is applied in unsupervised learning as well. As you could see, these are the unlabeled data. They are grouped into two different clusters based on the similarities and differences. Clustering techniques. It can be a hierarchical clustering or non-hierarchical clustering. In a hierarchical clustering, the data is organized into a hierarchy of clusters. That is, we are grouping the similar objects closer in the structure. For example, agglomerative and divisive clustering comes under this type. Non-hierarchical clustering, we divide the data into some fixed number of distinct groups. Say the unlabeled data will be grouped in clusters, say 2 or 3 clusters. So will be grouped under K clusters. For example, K means. So the main goal is to find the K most similar objects from a dataset. So we will be using a partial or a complete object descriptions and identify the clusters. For example, if we are searching for some relevant documents or images based on some query, that is a best example. So what is the outcome? It helps us to understand the relationships in unlabeled data. Also, it enables grouping and pattern discovery in large data sets. Semi-supervised learning. This combines the labeled and unlabeled data for learning. This is developed to overcome the limitations of using supervised or unsupervised learning alone. That is common in real world scenarios where labeled data is limited or expensive. So what is the need for semi-supervised? When we say labeled data, it is costly and it is hard. When we say unlabeled data, it's available and cheap. So semi-supervised learning uses both labeled and unlabeled data and helps us to improve the performance. The basic method is self-training. Let us consider U as a set of unlabeled data and L as set of labeled data. How the algorithm works? We will be training on this L, a set of labeled data. Then we will be predicting the labels for this set of unlabeled data based on this labeled data, and after which we'll add confidently some labeled instances from U to L iteratively. This is the algorithm. So the outcome would be unlabeled data starts contributing to the training process. Also, it's referred to as self-training in semi-supervised learning. Ensemble learning. This involves multiple learners or learning algorithms which are trained together. We combine the predictions from several base learners and improve accuracy. How it works. Each base learner is going to create a hypothesis. The final prediction would be a combination of all the hypotheses. So we go for voting or we average. Basically, it helps us to reduce the error. As you could see in this picture, yes, the training data, we supply different training data to the various learning approaches and later we combine the predictions. What are the types of ensemble methods? First one is boosting. The main thing is we focus on the weighted training sets and we increase the weights of misclassified examples and we combine the weak learners to form a strong learner. Whereas in bagging or bootstrap aggregating, we use bootstrap sampling, that is the data sampled with replacement. We train each learner on a different subset of the actual data. See the whole data set, we divide it into different subsets. So where the data sampling process happens with some replacement also. This helps us in reducing the variance and helps to prevent the overfitting. What is the outcome here? It boosts the performance by leveraging the strengths of multiple models. So it's commonly used in algorithms like random forest, AdaBoost, XGBoost. Discovery-based learning. It's a type of unsupervised learning. Here the learning occurs without any guidance from supervisor. Some of the characteristics includes, we also call it as inquiry-based learning. The learners rely on past experience and knowledge to discover the outcomes. It promotes exploration, critical thinking, and self-driven understanding. When we compare it to the supervised learning, in supervised, there is a supervisor required to guide it. That is, a label is required. Whereas in discovery based, there is no external guidance is required and the outcomes are self-identified. So the outcomes includes, it helps us to enhance the independent problem solving skills and it is ideal for situations where the label data is unavailable. Learning by problem solving. It resembles unsupervised learning. It focuses on the parameters related to the problem and solution. It aims to evaluate the desirability of an outcome or decision. It is based on how a problem is solved and the outcomes at each step. So in pattern-based decision making, categories are identified using the previous results. So this is what happens in learning by problem solving. In this video, we have learnt about the introduction to ML. Thank you.